All right, so what I did is I put two questions up here that were not part of the video because they're pretty easy and I think that you'll pick it up. All right, so we're going to do number 2. This one, it's a sum of squares, which if you guys remember is not one of the ones that you can factor. You can factor difference of squares, but not sum of squares. All right, so when you solve sum of squares, you are always, every single time, with no exceptions, you are always going to have a complex root. It will never be real. It will always be fake. Okay, and the method that you use is you just take the problem and you set it equal to 0. And so that's kind of like you saying, hey, I'm going to try to find the x-intercept of this. So anytime we factor problems, we're really looking for x-intercepts. And then here, we're not going to factor it, we're just going to isolate the x. So what's the first thing I can move to the other side? The 49. So I'm going to subtract 49 and subtract 49. And I get 4x squared equals negative 49. And then what can I do next? Divide by 4. So we're going to get rid of the 4. We got x squared equals negative 49 over 4. Will somebody just like hit her back really hard? Just thump it. You good? All right. And then the last thing we have to do to get the x alone is square root. And anytime we square root something, what should be in the front of the square root sign? Plus or minus. Okay. And I'm going to write this, I'm going to write this as a positive 49/4, and what should I do about that negative that was in there? Put it into an I in the front. Okay, now 49 over 4, what happens if you square root the top number and the bottom number? 7 over 2. So we're going to say our imaginary roots are plus or minus 7 over 2i. Those are the imaginary roots. If we had an imaginary graph, those would be the imaginary x-intercepts. But they're imaginaries, so they don't show up. Kind of weird, but that's how it works. Okay, I want you to go back to number 1 and try number 1. Anyone think they have the answer? Plus or minus 3i is perfect. Okay? So make sure you always get that plus or minus. Have we all noticed the dead animal zoo in the back? The animal that dies, if you don't put a plus or minus, is a duck. So if you don't want to kill a little baby duckling, don't forget the plus or minus. If you kill a little baby duckling, we will have to put a mark on the poster, and you will know that you killed it. Okay? And you will have to live with that for the rest of your life, that you killed a little baby duck. Okay?
You know how many giraffes I've killed?
I'm sure lots of you guys have been killing lots of animals and not even sure about it. All right, let's move down to the next one. So here, we started off by factoring using the sum or difference of cubes. This is like the first example from your video. And then after that, remember how I always said that the other part of the sum or difference of cubes didn't factor? Remember that? I also mentioned it last night. So, and the reason it doesn't factor is because typically it's an imaginary root. So, and you can't factor that, it's not real, it wouldn't show up. So, the process for this is first to factor using sum or difference of cubes, and then to use the quadratic formula on the leftovers to find the imaginary roots, okay? Number 3 is very similar to your video, so I am not going to do number 3, all right? Between number 4 and number 5, which one would you rather do? 4, okay. So the first thing we have to do to factor this using sum or difference of cubes is we have to write it as something third to the third minus something to the third. So if we multiplied something by itself 3 times and got 8x cubed, what should we have multiplied? 2 and an x, right? 2x. That's what we multiplied. If we multiplied something by itself 3 times and got 125, 5 would have been the number. Okay, so now I'm going to remember SOAP. And what should my first set of parentheses be? 2x, same sign, minus 5. Okay? The next thing, we take the first number and we multiply it by itself. So we're going to take 2x and we're multiplying it by itself. And what do we get? 4x squared. Then we do opposite sign. And then we multiply the 2 together. 2x times 5 is 10x. And then we do always positive. And then we do the last term times itself. 25. Okay. So this factor right here gives you a real root. What's the real root that it gives you? 5 halves or 5 over 2. Okay, that's a real root. And then for this, we cannot factor this. 99% of the time it's not real and you cannot factor it. So if we have a quadratic and we can't factor it, how do we have to solve it? Quadratic formula. Have to. Have to, have to. No other option. All right, so quadratic formula, if you don't have it memorized, let's write it down. It is Yeah. All right, so there's your quadratic formula. So make sure you have that written down somewhere today where you can access it, because we are going to be doing the quadratic formula quite a few times today. Okay, so if we take the problem that we're working on right now, then what are we going to start with? Negative 10, so that's our negative b. And when it says negative b, it really just means take the opposite sign of the b that you can see. Okay, so we can see a positive 10, so we take the opposite sign. Then what do we write? So b squared minus 4 times a times 25, which is your c, divided by 2 times 4. All right, and I did not leave you very much room. I'm sorry, I was trying to kill less trees. So if you feel like you can't write small enough to put it on this worksheet, you are always welcome to do a separate sheet of paper. Okay, and just make sure you staple them. Okay, so I have x equals negative 10 plus or minus the square root of something, all divided by 8. Why am I not plugging all of this into my calculator at once? It would give me an error message. Okay, so I'm only going to type in the part that's underneath the square root sign. So 10 squared minus 4 times 25 is negative 300. Okay, so as soon as I see that negative, what do I do? Positive, put an I there, okay? And then with that 300, I have to do a little factor tree. Anybody? You could do 2 times 150. Do we want to do 3 times 100? Okay. 3 times 100 works. 2 times 150 would also work. You wouldn't be wrong. 3 times 100 is fine. Okay? And then what do we have? 10 times 10. Now, technically in a factor tree, you keep breaking it down. All right? So we could do that. But when you do 10 times 10, you can actually say that you're done. All right, so if you continue to break it down, then you're going to get a pair of 2's. and a pair of 5s and a leftover 3. So what we're going to say is that the pairs we multiply together and they go in the front. 5 times 2 is 10, so 10 goes in the front. And then there's a leftover 3, so 3 goes inside. All right? So we have negative 10 plus or minus. We had a pair of 5s and a pair of 2s. And 5 times 2 is 10, so 10 goes in the front with the I. We had a leftover 3, and the leftovers always go inside. Now, some people always bring it down as far as like the very furthest you can bring the smallest factors. However, you could have looked at that and been like, oh, 10 and 10, that's a pair. Let me just put a 10 out front. And you could have ignored the last step. And you would have still gotten it right. Okay, so if you want to do it until you see the pairs, that's fine. If you want to go all the way, that's fine too. Okay? All right, now if I look at this, I cannot touch the 3, but do you see how all the other numbers are all even? So that means we should divide out a 2 of all the other numbers. So my final answer for the imaginary, for the complex root would be negative 5 plus or minus 5i square root of 3 divided by 4. Now, it seems like these are a little bit tedious. I wouldn't necessarily say they're hard. I would say they're tedious because there's a difference between those. The nice thing about this worksheet is that these problems are very repetitive. So it's not different every time. It's just a lot of the quadratic formula and then simplifying the quadratic formula. Okay, that's most of what you'll end up doing today. How did we feel about that process? Not fun, but we've done worse things. Yeah? Okay. Let's look down at the next ones. So here, if it's not the sum or difference of cubes, and it's not the sum of squares, then that means we're probably going to get our graphing calculator out and start off by looking for the real x-intercepts on the graphing calculator. So go ahead and grab your calculators. And in the y equals screen, I'm going to type in number 6. Or would you guys rather do number 7? 7? Number 7? Okay, let's do number 7. So I've got x to the 4th minus 3x to the 3rd minus 23x to the 2nd plus 147x minus 234. Do I have to mess with my window so I can see the whole thing? No, I don't care to see the whole thing. What do I need to be able to see? The x-intercepts. All right, so what do we think the x-intercepts are? 3 and negative 6? Okay, so I'm going to write down on my paper my predictions are negative 6 and 3. And what do I do to double check that I have the right numbers? Second trace, number 1, because I'm plugging a number in. And what number should I plug in? Negative 6 and 3, right? So if I plug in negative 6, my y-coordinate is 0, which is what I wanted, so that means it's an x-intercept. If I plug in 3, my y-coordinate is 0, that means it's an x-intercept. Okay, so that means I got them right. Okay, so now we are mostly done with the calculators. You can use it for your computations if you need to. And then which number do we work with first? It does not matter. Okay, which one do you guys want to use first? Negative 6. Okay, so negative 6 goes in the box. And then what do I do next? The coefficients. I write down the coefficients. So positive 1, negative 3, negative 23, positive 147, negative 234. Yeah.
For the box at the bottom, is it always 0?
It's 0 for these problems. If it's a real x-intercept, it will go in evenly. There will not be a remainder. But when you guys learn synthetic division, we learn to use it in different cases where there could be a remainder. So for synthetic division, it can equal anything at the end, but for this type of problem, it has to be 0. All right, so we have the 1, we drop that down, and then what do we do? Multiply by -6, and I get -6. And then what do I do with those two numbers? I add them together. Okay, so add them, I get -9. And then -9 times -6 is 54, but positive, right? Because a negative times a negative makes a positive. And then -23 plus 54, 31. And then 31 times -6. Ooh. -6. -186.
Hello?
Yes?
Hey, is there a responsible student to come down and grab the attendance?
So we don't need to anymore because I came.
Oh, you did?
This is Miss Rice,
Is
yeah.
this Miss Rice?
Yeah, I showed up early.
Hey, Miss Rice.
Okay.
Okay, I'm going to cross your substitute outfit.
Okay,
Okay, thanks, hon.
yeah. My sub that didn't show. I'm glad they noticed at 11:20. All right, positive 147 and negative 186 gives you what? Negative 39. Okay. And then, and then when you multiply those, you get 234 like you should, right? So that's good. That's a good sign. Okay, what do I do next? Next number. All right, so 3. And do I start at the beginning and just use the original numbers? No. All right, use the ones we finished with. When students get really frustrated with these, it's usually because they went back to the original numbers and they just like keep doing the problem over and over again and not getting anywhere. So be careful of that. All right, so we drop down the 1. 1 times 3 is 3. That gives us -6. -6 times 3 is -18. When we subtract those, we get 13. 13 times 3, 39. Marvelous. Okay, so the quadratic that we are dealing with, we have x squared minus 6x plus 13 equals 0. Is this going to be factorable? No, absolutely not, never. If it was factorable, we would have seen the answers already on the graphing calculator screen, okay? So these answers are guaranteed imaginary. No chance for them to not be imaginary. They have to be imaginary. And that means we have to do the quadratic formula. Okay, so what should I write? I've got 6 plus or minus -6 squared, so I'm writing super tiny, minus 4 times 1 times 13, oh gosh, all divided by 2 times 1, which is 2. So 6 plus or minus something divided by 2. You said that already, right? -16. All right, -16. I take the negative, I make it a positive, and I put an I. And what's the square root of 16? 4. So I have 6 plus or minus 4i divided by 2. Can I divide those numbers by 2? Yes. So I'm going to say my final answer is 3 plus or minus 2i. Perfect. There's so many. All right. We're going to scooch over to number 8. See that scooch? That was pretty good. All right. We're going to graph it. All right, what happened when you graphed it?
Did you graph it how it's on the paper, or did you flip it?
I graphed it exactly the way it is on the paper.
It doesn't have any x-intercepts.
It has no x-intercepts. So what does that mean about the roots? They're all imaginary. There is no real roots in there. So that means we cannot do synthetic division. Can't do it. Okay? So that means that with this problem, we got to put the calculator away. Can't use it. Sorry, folks. Oh, man. We're going to treat this problem kind of like a 5x squared plus 6x plus 1. We're going to treat it like that. Okay? But when we factor a problem like this, our factors would have an x and an x, right? But we have higher exponents. Thank you. We have higher exponents, so ours are going to be x squared and x squared. Does that make sense? So we're going to treat it like a problem like this, but our factors are going to have x squareds in them. Okay? So this problem right here, it has a coefficient, the a value does not equal 1. So that means our options are slide, divide, bottoms up, box method, or grouping. All three of those methods would accomplish the same thing. So what method do you guys prefer? Slide divide? Yeah, slide divide? Okay. So for slide divide, we're going to say 5 times 1 is 5. So we are multiplying to 5 but adding to 6. And the two numbers that do that, 5 and 1. All right. So we're going to say our factors are x squared plus 5 and x squared plus 1. So we did the slide part. Now we have to do the divide part. And what do I mean by the divide part? Divide by 5. So the number we slid is the number we divide by. And we simplify our fractions if we can. Do we have a fraction that simplifies? Yes. 5 over 5 is just 1. Okay, so that's x squared plus 1. And then for the fractions that are left over, we bottoms up. So what should the other factor be? Okay, 5x squared plus 1. So the reason that we didn't see any x-intercepts on the graph is because we have a sum of squares here. And we have a sum of kind of squares here. But both of these have sets of imaginary answers. So that's why when we graphed it, we didn't see any real answers because there weren't any. There were only imaginary answers. So I'm going to say x squared plus 1 equals 0. And what should I do? Minus the 1. So x squared equals negative 1. And then what should I do? Square root. So x equals plus or minus I. Right? So I see that negative with the 1. I'm going to make that an I in the front. The square root of 1 is just 1. So we have plus or minus. You can write I or you can write 1I. Either way you write it is totally fine. So there's one set of answers. Over here we have 5x squared plus 1 equals 0. So what do I do with this one? Subtract the 1. 5x squared equals negative 1. Divide by the 5. X squared equals negative 1/5. And then what am I going to do? Square root. So I have plus minus the square root of negative 1/5. What do I do with the minus? Change it to a positive. Put an I in the front. And I'll say that for, normally I'd have you fix these answers, but for the purpose of this assignment, I don't want to overwhelm you. So I'll go ahead and leave it just like this. So plus or minus I, square root of 1/5. Or you could say square root of 1/5 and put the I after it. That's fine. It's whenever you have a number that's like a fraction or a whole number, we typically put the I after it. When you write stuff that where your answer's left over, like the quadratic formula, then the I often goes right in front of the square root sign. So when you have an answer that's just a square root, it doesn't look weird to normal math people to have the I in the front. That's kind of normal for us. Whole numbers, number 2, we're never going to write I2. We're always going to write 2I. All right, so the only exception to that is typically with the radicals, putting the I in the front is not weird because that's how it shows up in the quadratic formula. Okay. How are you feeling about finding these complex roots? So what are some things that we have to remember to check for today? So we're going to check for the imaginary roots. We're always, with these problems, we're going to graph it first because that's going to help us do our synthetic division. And then what formula should you use a lot of times today? Quadratic formula is going to happen a lot. Synthetic division, but quadratic formula you're going to use a lot. Okay, sound good? All right, go ahead and get started working on those.